Solve the following quadratic equation for x by completing the square. And here we have the quadratic equation 2x squared plus 7x plus 3 is equal to 0. So to begin, let's recall how we complete the square. Voila! So if we are given a quadratic expression of the form x squared plus bx equals 0, where again our leading coefficient is equal to 1, then we can solve by completing the square by adding half of the b coefficient squared to both sides of the equation. And again, what this does is it forces a perfect square. It's going to create the square of a binomial. So here we go. So in this case, we are given 2x squared plus 7x plus 3 is equal to 0. Now, wait a second. Notice here that our leading coefficient is not 1. It's 2. So we need to get rid of this 2. Right? In order to complete the square, we need our leading coefficient to be 1. So let's start here by factoring a 2 out of each term in this quadratic equation. So I'm factoring out a 2, so I'm left here with x squared plus 7 halves times x plus 3 halves is equal to 0. So we factored the 2 out in front. And now let's get rid of it. Let's divide both sides of this equation by 2. So we can see 2 divided by 2 cancels itself out to 1. And we are left now with x squared plus 7 halves x plus 3 halves is equal to 0. So we have made the leading coefficient 1, but keep in mind that in order to complete the square, not only does that leading coefficient need to be 1, but we also need to have this x squared plus bx isolated on the left-hand side. So in order to isolate that, we need to now subtract this 3 halves from both sides of the quadratic expression. So we have 3 halves minus 3 halves cancels each other out to 0. And now we are left with the perfect format. We have x squared plus 7 halves x is equal to minus 3 halves. Beautiful! So we have set this quadratic expression up perfectly to now go through and complete our square. So looking at this quadratic equation, we can see that the coefficient b is 7 halves. So we're going to need to now go ahead and add half of this squared to both sides of the equation. So this is going to become x squared plus 7 halves times x plus, so we're going to have 7 halves divided by 2 squared added to both sides. So this is equal to minus 3 halves plus 7 halves divided by 2 squared. So let's step to the side real quick and think about what we've just added to both sides. So we have, again, 7 halves divided by 2 squared. So let's simplify this a little bit. We can think about this 2 in the denominator as being 2 over 1, and we can rewrite this now as 7 halves multiplied, right, fractions in the denominator flip, so we multiply by the reciprocal, 1 over 2 squared. So this is leaving us with 7/4 squared. Now remember, this simplified number is important when we get to the square of the binomial. So let's actually plug this back into our quadratic equation above as it's written. So this is x squared plus 7 halves times x plus 7/4 squared. And this is equal to negative 3 halves plus 7/4 squared. And again, remember that 7/4 is going to be important. So let's keep simplifying. So we can now rewrite this as x squared plus 7 halves x plus, so we have 7 squared is 49, all divided by 4 squared, which is 16, this is equal to minus 3 halves plus 49 sixteenths. So on the left-hand side, although it looks a little scary, we've actually completed the square. Remember that 7/4 that we identified above? That's the perfect square. So we can rewrite the left-hand side in its factored form as x plus 7/4 times x plus 7/4. Woohoo! Now with the right-hand side here, we need to get a common denominator. So we know that 16 is 2 times 8, and the other denominator has a 2 in it. So let's multiply this first fraction, the numerator and denominator, by 8. So this will leave us with negative 24 plus 49, all divided by 16. And we can rewrite this further. We can see again the square of this binomial, x plus 7/4 squared. And this is equal to, we have 49 minus 24, which leaves us with 25 sixteenths. And so we have officially completed the square. Woohoo! So now that we have completed this square, we're ready to apply the square root method. So giving ourselves plenty of room, we're now going to solve for x by the square root method. So we are going to take what we found in the previous step, the completed square, and now in order to solve for x, we need to get rid of that square. So we are going to take the square root of both sides of this equation. So on the left-hand side, we see the square and the square root cancel each other out to x plus 7/4. And this will be equal to plus or minus. Now let's actually think about this algebra. If we're thinking about the square root of 25 by 16, we can rewrite this as the square root of 25 divided by the square root of 16, which are both perfect squares. We know that 25 is 5 squared and 16 is 4 squared. Woohoo! So this is going to simplify to plus or minus 5/4. Beautiful! So now to solve for x, we are going to isolate it by subtracting 7/4 from both sides of this equation. So we can see that the 7/4 minus 7/4 cancels itself out to 0, and we are conveniently left with a common denominator. We have that x is equal to minus 7/4 plus or minus 5/4. So in this case, we want to go through and think about each case separately. So we're going to go ahead and we'll think about the positive case, where we're adding these terms, and then we'll also think about the negative case, where we're subtracting the terms. So case number 1, we have x is equal to minus 7/4 plus 5/4, which is going to leave us with a negative 2/4 or minus 1/2. And then in the second case here, we have x is equal to minus 7/4 minus 5/4. So we have minus 7 minus 5 gives us a negative 12/4. And we know that 4 goes into 12 3 times. We're left with a minus 3. And so we have both of our solutions. We can say that therefore x is equal to negative 1/2. That is a 2. So let's rewrite that poor 2 there. That's negative 1/2. And we've also shown that x is equal to negative 3. And so these are our beautiful final answers here.